We're so happy that you've joined us for the Teaching with Tinkercad webinar. So this is episode 3. So today we're going to be focusing on making hands-on work in a digital world. Again, you have all been doing this all year, particularly last year and into the new year. So we would love to hear from you. And we're also going to hear from some teachers today in regards to how they made hands-on work this year and how they're continuing to do so with their students. So my name is Kellyanne Mahoney. I'm a youth program specialist at Autodesk. I'm also a former teacher. I'm a national board certified teacher as well. And I taught in the Boston Public Schools for 11 years, or 13 years actually, before joining Autodesk. Jenny, do you want to say hi?
Yes, hi everyone. I'm Jenny Fennell. I'm the content manager for youth education here at Autodesk, and I'm based in Portland, Oregon.
Thank you, Jenny. And for those who hear us saying Autodesk, you might be familiar with Tinkercad. Tinkercad is part of the Autodesk family, so we'll talk a little bit more about that. Instructables is also another great resource that teachers and students can find inspiration from. And these are just ways to connect with us. So the hashtag Tinker Together or hashtag Make Anything. We love to hear your Tinker Together stories and your Make Anything stories over social. So our social handles are at Tinkercad and also at Instructables. Today, I am so excited that it is a teacher double feature. So we're gonna have two teachers joining us for this episode. They are both superstar talented teachers from the Boston Public Schools. Mika, do you wanna say hi?
Yeah, hello everybody. I am the K-8 computer science specialist at a school in the North End neighborhood of Boston. This is my 3rd year in the role, and before I happened into it, I was a special ed teacher.
Thank you so much, Mika. Panion, you want to say hi?
Hi, I'm Panion Tase. I guess I'll reserve the rest of the time for later.
Well, thank you. And I do think that also these two teachers coming together to tell their stories really also tells an interesting story from kindergarten into high school. So Panion teaches at a high school in Boston as well. So you're also joined by the Tinkercad, Autodesk, Instructables team. So we're really happy to have you here. You are super supported by us. These are the real life people, real life humans who will be answering your questions in the chat. So please feel free to ask us questions, particularly questions that you want us to answer in the question and answer through the question and answer, and then keep that conversation going with each other in the chat. So goals, we do have them. So our goals today is, so in hearing your comments from the last webinar, you were asking for a slower demonstration of Tinkercad. So we're going to talk about that, but also within the context of how you can get started with Tinkercad, even if you've never taught Tinkercad before. My sub-theme for this is you've got this, you can do it. And the teachers who are here will definitely their stories will encourage you to realize that for sure. Also thinking about how to help students make interdisciplinary connections by learning Tinkercad. We also heard a lot from teachers during the last episode about how you would like to learn more about the circuits editor within Tinkercad. So Panion is actually going to provide us with a demonstration of how he gets his students started with circuits. And then lastly, please stick around to the end so that you can ask questions to not only the Tinkercad team, but also the lovely teachers who have joined us tonight or today, wherever you are. So this is just kind of the map of the journey that we will be embarking upon this evening or this afternoon. So we're going to start out with just a little bit of general knowledge about Tinkercad for those who are just joining us. We're going to hear some inspiring stories about students, particularly Mika is going to talk about how she's used Tinkercad this year in order to empower student voice in her classroom and to make learning student-centered even within the constraints within she's working right now. So just talk a little bit about that. I will share with you a resource that could help you getting started with Tinkercad, and that is the biomimicry lesson plan that I wrote. So we'll talk a little bit about that. Panion on step 4 is going to be providing us with a circuits demonstration. He's also going to share some stories from his classroom and from his students. And then lastly, again, please stick around for the question and answer. So general knowledge. So if you're new to Tinkercad, Tinkercad is a creativity tool that students can use in order to 3D design things like a car, for example, or also even, 3D print them if they wanted to think about, making a car move, for example, or not. Tinkercad is also a great tool, for students who are thinking about like spatial awareness or, learning about architecture, for example. So you can see within Tinkercad, there's tools for measuring and, thinking about things like scale and proportions. It's also a great tool for thinking about things that you might build that have structural integrity. So this is actually an example of how you could design a bridge computationally. And then you could even have students build them in real life with, things that they find around their house, like popsicle sticks, for example, or, other recyclables. And then lastly, one of the reasons why I love Tinkercad the most is because I think it's a really wonderful vehicle for your students to be able to express themselves through STEM, and not only just express themselves, but actually see themselves in STEM, which is really important for our students. You should know that Tinkercad is part of the Autodesk family. So Autodesk is a global software company. We make software for people who make things, particularly design professionals and construction professionals. If you've ever driven in a high performance vehicle before, or a smart car, if you stood in awe at a skyscraper or marveled at the engineering of infrastructure like a bridge, or if you've really enjoyed playing a blockbuster video game or watching a film that has computer graphics in it, chances are you've engaged with something that our customers have made with Autodesk software. So if your students really love Tinkercad, which we hope they do, know that as they get older, for example, when they turn age 13, they also have free access to about 100 different professional tools that they could learn for free as well. So our tools are all free, or at least about 100 of them are free for teachers and students and schools. So you can go to that page, and it's linked in the presentation to learn more about that. So Tinkercad is web-based. Again, it's free. It's free actually for everyone. And it's a really great creativity tool for your students to be able to take an idea that they have in their mind and bring it into reality in minutes through design. And later on, they could also fabricate it or make it too, or not. So Tinkercad works really well on Chromebooks. It works on iPads as well. One of the cool features in using Tinkercad on an iPad is the augmented reality feature. So your students can also take their ideas and unleash them into the real world through augmented reality and using the Tinkercad iPad app. There are 3 environments within Tinkercad. So there's the 3D design editor, which you might be the most familiar with. There is electronics, or the circuits editor, and there's also code blocks. So if you missed episode 2, there was actually a wonderful demonstration of code blocks from our friend, teacher, Mr. Stephen Jones. So we'll show you later how you can check out the recordings of the webinars as well. Today, we're going to be focusing primarily on the circuits environment, but we will talk a little bit about the 3D editor as well. But Panion is going to tell you about how in the past, particularly, he's a teacher who has done not only Tinkercad circuits, but also real life hands-on electronics and circuits in his classroom. And this is a really great visual of how you can do things like coding an Arduino or making an LED light blink, but you can also simulate it so you're not breaking your electronics parts in real life. So why teach students electronics? One of the things that we think about in terms of why learn electronics is it helps foster an engineering mindset in students. So this is a cool graphic that I found that is from the Royal Academy of Engineering in the UK. And I think it's a really great illustration about how when you're teaching things like electronics, you're not only teaching those hard skills like systems thinking and creative problem solving and adapting and visualizing and really, thinking about criteria and constraints, but you're also teaching kind of more broader skills like curiosity, open-mindedness, resilience. And this is also, you could use this as a framework for even assessing students. But the cool thing about circuits and, teaching things like physical computing, for example, is it really brings an efficacy, I feel like, for students in a way that other kind of activities might not. Because, for example, if they're trying to get the LED light to blink, by programming the Arduino and using the breadboard that you see here, once it blinks, they know that they did it right. They don't need a teacher to tell them if they did it right or wrong. And that's really empowering for students. Have no fear if you're intimidated about learning circuits or learning electronics. Within Tinkercad, this is actually within the 3D editor itself. There are so many resources. So this is like within the 3D editor, there are assemblies, and if you click on them, it shows you, the NeoPixel assembly and how you can use it, and it links to an Instructable. So there's tons of resources, and Panion is going to go more deeply into that. But it's also a really cool activity to get your students thinking about not only circuits, but then also 3D design and how you can combine them and really kind of make impact in the real environment. So taking your 3D design and then in real life, making it blink or making it move. So before we move on to the next segment, we talked a little bit about habits of mind. Please let us know in the chat, what are some habits of mind that you think are most important, either for the subject area or the grade level that you teach? So please let us know in the chat. I mentioned flexibility this year, I think in particular, is really important for all subjects. You could just tell us in one word. Jenny, any interesting ideas in the chat?
We have a couple. Falling forward, perseverance, open-mindedness, art, curiosity. All of the things, but if I had to pick just one, it's creative problem solving, crosscuts with design thinking practices we dive into with our projects.
Nice. And we're going to talk a little bit more also about those kind of cross-cutting concepts or ideas that even can help us empower interdisciplinary learning in our classrooms as well. So please keep letting us know in the chat about habits of mind, and please also feel free to connect with one another in the chat. So next up is Mika, and Mika is going to tell us about how she's empowered student learning in her class through using Tinkercad. So Mika.
Hi again, everybody. I was introduced to Tinkercad actually by Kellyanne this past summer, and it was such a great thing coming into this year of virtual learning and now transition to hybrid. I'm in week 2 of sort of hybrid. And I'm just so grateful to have Tinkercad to play with my students. So I work on Tinkercad with my 4th to 7th graders. And on day 2 of my classes with them, we just dive right in. I do a quick demo of an ice cream cone because it shows a couple of tips and tricks skills that I want them to just be aware of. But otherwise, I just want them to figure things out and make things that they want to make. I give them a little form that they can use kind of scavenger hunt style to practice some different skills, leave some questions and comments. And then we just keep rolling on to the rest of our projects. So in addition, and of course, here's some of the free create designs that my kids generate just on day 1, and they're so cute. And the kids are hooked right away, and it definitely feels very hands-on, even though we're just in a digital space. So in addition to that Explore Tinkercad like Superflex day, another introductory project I do is adapted from the Stanford Design School's 5-chair challenge, where the kids will check out some user profiles, some Simpsons characters that we see here, work on some sketches to make their brain so stormy before they then go model their designs in 3D. And the range of chairs that are produced in just a very quick 2-day challenge really sets up the kids to launch into our more in-depth work. And something else we do in addition to Tinkercad, one of my top favorite teacher tools for virtual learning is Padlet. And this is where we put all of our designs and just sort of put together just a community of creators here commenting on each other's designs and that kind of thing. So once those introductory challenges are all set, we dive into our core projects. So as Kellyanne mentioned, there's a bunch of lesson plans that are available and written by awesome people like Kellyanne. So I took 2 of the projects from that lesson plan page, the personal avatar and dream room, and just kind of adapted it into my own module that I call digital identities. So for that first project of personal avatar, like you saw with the chair challenge, we get going with sketches and then hopefully, think of multiple ideas that we can possibly run with once we get into our 3D design. And then once the kids are there, it's just such an awesome expression of like who they are and like how they decide to represent themselves. Sometimes it's, more of like a realistic approach. Sometimes it's a character that they feel like they have a great connection to. Like adding on, there's just so many different add-ons that like I don't even prompt, the kids just like go and run with. Everything from, being represented as an artist or a dragon tamer. And this is a really good transition into the like sort of culminating project of digital identities, which is Dream Room. So we start with layout sketches, and then once we hop onto Tinkercad, oftentimes the dream rooms turn into like dream compounds. But whatever the case may be, whether students are focusing on a room and the details within that, or they can, keep running with it and add on to whatever their ideal space is. It's a great representation of like, who the kids are. And there isn't like any stopping point. Like we get to a wrap up point because like, we have like a certain amount of time with each other. But the kids like could easily keep going, and they often do. So with my 6th and 7th graders, I once again turned to the lesson plans that are right on Tinkercad. And I took the biomimicry lesson that's going to be touched upon a little bit later, and a pollution problem lesson, and turned it into a nature's designers module. So for the biomimicry one, I shifted it a little bit and focused more on architecture. So we look at biomorphic and biomimetic architecture that's out in the real world. And then once again, do sketches. That's always the brainstorminess that launches us into our work on Tinkercad. And then the kids, and a demo that I do for this is using the duplicate and repeat tool to make the connections between patterns that we often see in nature, and this really great resource that's just built in right into the environment. So I do this with a succulent demo, and then a lot of kids use this tool in their designs as well. So as you can see, a big range of builds between the spectrum of like more biomimetic, like copies of things from nature, and biomorphic, like things that just like make you think of things from nature. And once again, like similarly to the Dream Room projects that we took a look at with 4th and 5th graders, these 6th and 7th graders like can keep going and adding on to their design, like making it feel like within a broader space. So after we create our nature-inspired structures, we look at pollution problems and solutions that are out there, which given the urgency of climate change happening right now, like the kids really know that, leads us to our pollution reducing device project, which has a huge range of like what a device means. Everything from like a campaign to something that you might use at your home to something that might impact industry. And the creativity here is really awesome, and as well as the collaboration. This is a project that I have students work on in teams. And I think I saw in the chat earlier some folks mentioning that there is a collaboration link that you can send to other people. And my kids have loved working on the projects together, and it really continues to like drive their learning with 3D modeling skills, and then also generating ideas that could really make a difference. So as you can see, I am a total like spokeshuman for all things Tinkercad. I am so grateful that I was introduced to this summer. It has been, like I mentioned earlier, like just the most hands-on feeling like digital experience that I can offer my students. like within the context of virtual learning. And I am totally going to bring this super powerful platform to the work we do once we come back into the classroom, hopefully.
Thank you so much, Mika. And we appreciate you as well. And we appreciate you so much that we made you an emoji. Actually, Donald did. So this also, I love how Mika has her kind of go-to, kind of quick succulent starter that she does with their students. But we thought that we'd also share with you this kind of fun emoji activity that you can do really quickly with your students. You can also use this demonstration later with your students to get them started, because it's really simple to do. You see Donald here is just dragging out shapes. So we put a heart shape. I'm wondering what he's going to do with that now. And you see that he's just dragging the shapes out onto the work plane. He's pushing and pulling the handles in order to make them smaller or bigger and change the size. You could see that he just duplicated it really quickly. He's using his camera controls in order to be more kind of precise in terms of his designing. He's going to be fancy, I think, next and pull out a different shape, a cylinder. And you see when you pull out the shapes that they're solids, but then you have the option to also turn them into holes. So he's going to show you that in a moment as well. And the reason why you would do that is just so that you can subtract from the shape. So he's making, I think that he's trying to show that it was just really awesome what Mika made for us. So next, where he turns it into a hole. And then he just duplicated it. So he did just Command D to duplicate it. And the reason why he's making it a whole and then combining it together as a group and grouping it is to kind of give a little bit of a three-dimensionality to the emoji, which is super cool. And then he's going to turn the color again, make it solid. And then there you go. So this is just a fun, quick starter activity that you could do with your students. Students, I think, still like emojis as well. Maybe my teacher friends can help me. I feel like teachers are much cooler adults than others. They know all the cool things. So please tell us all the cool things now. Let us know in the chat, what's your go-to design or activity to get students started in Tinkercad? So Mika shared with us her succulent design, which is also a really great demonstration of Smart Duplicate, which I will actually show you how to use a little bit later when we talk about the biomimicry lesson. Also, you could do an emoji, which is a fun, quick starter. Jenny, any ideas in the chat?
There was a whole bunch of stuff coming in. Let's see, basic circuit lessons, Minecraft glasses.
Ooh, that's
yeah. We designed board games, and they designed their meeples for their games.
Oh, cute.
We have keychains and custom ear savers, creating molecules.
And on the Tinkercad Learn page, there's also some really fun starters, activities and lessons as well that provide kind of more step-by-step scaffolding too for your students. So please keep those ideas coming. They're not just helpful for us to know, but I think it's helpful to share with other educators as well. So next, I'm just going to quickly run through one of the resources that Mika talked to you about, which is one of our Tinkercad lessons, which is the biomimicry lesson. Most of these lessons can all be found on the Teach page. And most of these were written by teachers for teachers. I think I'm the only non-teacher that's written one so far, but I used to be a teacher. So this is the biomimicry lesson. One of the things that I wanted to showcase to you is also just a lot of the resources that are included. So different types of media resources as well, in addition to the alignment to standards. So this one happens to be aligned with the ISTE standards and some Common Core standards. You see that there are step-by-step instructions. There are, in this particular lesson, there are PowerPoints. I really wanted to make this as plug and play for teachers, and also just to kind of take students and teachers on a journey through different subjects as well. So it starts in math, it goes into art, and even does a little coding. It gets into architecture. There's a lot of vocabulary. I'm just going quickly through this. So there's vocabulary, really reinforcing the concept of what biomimicry is. So using nature as an inspiration for design. It talks about different scientific concepts. So for example, bioluminescence. So thinking about materials when you're designing and building. Again, it talks about, what biomimicry is and what it isn't. It presents a design challenge and also, inspires students to do research on climate change, to do some design thinking. You could also not do all of these things and kind of chop it off and do what works for you. So it's broken down into different steps. And at the end of all the lessons, there is some scaffolding for thinking about how to help students communicate their ideas, which we think is really important to the design process. There's also, in addition to PowerPoint, some of the lessons have worksheets. So this one, for example, talks about engineering mindset, and it provides you with some worksheets for students to be able to use to think about criteria and constraints as they're designing. Other media that some of the lessons include are also videos. So for example, in this biomimicry lesson, it takes that the abalone house that you saw previously, that building that looks like it's inspired by a mollusk shell. So not only by its beauty, but also by its engineering. And as you see here, I am creating the abalone house, starting out with the scribble tool, which is really fun. And I'm just going to play this for a little bit because Mika talked about smart duplicate. And this is just another example, which is kind of, I feel like, a Tinkercad superpower. So what you see me here doing here is Command D to duplicate it. But one of the things about smart duplicate that's really fun is it doesn't just remember the shape. It can also remember if you make an adjustment to the size, which you see me doing here. And also even like the angle, if you're rotating it a bit. And then I just keep hitting Command D, Command D, Command D over again. And really quickly, you have this cool mollusk shell shape, or clam in particular is what it is. So in thinking about sparking new ideas and new ways of collaborating in the new year, let us know in the chat, how would you spark collaboration with another teacher to try out an interdisciplinary lesson or project? For example, Mika, when she was talking about how she took the lessons, I thought it was really creative and connected them with themes. I feel like is one strategy that I would use as a teacher to think about how I could make things interdisciplinary, is kind of choosing a really interesting theme like nature's designers or digital identities, because those tend to cut across different classes. What are some of your tips or tricks for thinking about how you could spark collaboration with another teacher to do a project? Another one that I can think of as you're typing is even to think of something that is kind of burdensome or hard for teachers, like assessment, for example, and grading all those papers or grading all those presentations. It becomes easier if you're doing a project together with another teacher that you can then split up the work and grading it. Anything in the chat, Jenny?
There's a couple things. I work with math teachers and design stairs and trusses.
Nice.
We have another comment. Social studies, I'm art. I've been thinking they could design a Mayan sunstone.
Ooh, that's really cool.
Another attendee says, I've been working with the art teacher making the Murakami flower in Tinkercad versus freehand.
So cool. I feel like science fair is another one. The science teachers are always so cool and interesting and nice. And I feel like they get so overwhelmed during science fair. So what are some ways that, other teachers can help them with that? Any other ones, Jenny, before we move on?
There are a couple more. Print and paint and math and art is a collaboration.
I love math and art collaborations.
Yeah, it's very creative.
So cool. Well, keep letting us know in the chat. And we're going to move on next to Panion, who is going to provide us with a demonstration of circuits. But before he begins, he's going to tell us just a little bit about his background and the school in which he teaches as well. So Panion, take it away.
Hi guys, I reserved my time for a reason. I was going to do the introduction here. Before the hand though, I just wanted to say thank you to everyone that's here, especially I saw some people in chat from Germany and Ireland. Super late for you guys. Really, really awesome that you're here. So a little bit of information about my school and our population. So we're located in Boston, and our school is very unique because we're 100% immigrant students. The time that the students have been in the US is anywhere from 3 weeks to 3 years. And generally we start the school year with about 270 to 300 students, and the school year with about 500. So there's always an influx of new students, which makes things interesting and challenging at the same time. Our students speak over 35 different languages and come from 30 different countries. So we try to build like that cultural part. So I talk a bit about this because I want to also talk a little bit about my experience as ELL teacher and ELL learner. So I came to the United States about 20 years ago, and it felt like that time it was kind of like immigrants can't achieve much. They need to learn English and forget about all the other stuff. And they just need to understand the way that teaching happens in America, not, like anything else. And this was kind of seemed to be somewhat true then, and sometimes even now. Number one, definitely not true. Students need to learn English, but they also need to feel accomplished and proud and productive during this time. And learning the way that teaching is done in America doesn't happen just by giving worksheets. So with this, I try to keep this mentality with my students as we kind of go through our classroom. So why do I bring that up? I bring it up because of Tinkercad. So a few years ago, I realized that, Kellyanne, if you can, thank you. I found out Tinkercad, and I found out how flexible and amazing and incredible it is. Number one, is incredibly easy to learn. Just like Mika said, from day one, they can create something really cool and something that they can take ownership of. But it's not just like cool on the first day and limiting, it's also very flexible. As students' skills grow, they can do a lot more cool stuff. So here's an example of a lithophane, and students really enjoyed because it connected to people that looked like them or people that had the same interests. So it was connected to their own personal experiences. Also, I find that Tinkercad fosters teamwork, collaboration, imagination, because it can be done for a lot of cool things and can be done often. So I also love that there is an ongoing development of the program, not just within Tinkercad, the design part, but also the code and the circuits. So it really allows to have that kind of flexibility. So Tinkercad really kind of inspired change for us. I kind of went in this with the same idea as Mika in terms of showing the students or having the problem in our classroom. So here's a picture from my class, and as you can see, the students are really crammed together. There's a computer, there's about 2 or 3 inches of space between the keyboard, and that's basically where they can put their hands in. And you can see the tables are sagging, and it just definitely does not feel like a very welcoming environment, and it's definitely not a place where you'd want to work. So I challenge the students to recreate the classroom, how they vision it, how they see it. And basically, we want to create something that was relevant to the students, and Tinkercad allowed to do that because it was their classroom. It's the place where they came in every single day. It was something that was real world. It was connected to their everyday experiences, and everybody could do something. People could find out their interests. They could find out their abilities of what they could do. So some people were really interested in design. Some people were interested in the coding, and some people were interested in the circuits. I love that somebody did mention the fail forward. That's my mentality in class, in school. You have to fail forward and fail often, but that becomes very costly, especially if you're buying material. So by having Tinkercad, it really minimizes the costly mistakes. And when I say costly mistakes, I mean costly mistakes, because we actually did build that. Whatever the students designed, we actually did build, and we stayed true to the design. I mean, this is a 24-foot long table that we barely got in there by 3 inches. And, we went through and spent hundreds of hours working and designing. And none of this would have been true or possible if it wasn't for Tinkercad. Tinkercad really allowed the students to design something, build something, and when everybody could see it, they could actually build it because they believed in the concept. They believed that what was happening was going to be finished, and they were able to actually work together and collaborate. And just in this shot, you have a student that's from Vietnam, Cape Verde, Haiti. I can't see anybody else because the video is actually not moving. But they actually came together from different languages. Most of the students they're not actually even my students. They're not even in my class. Most of the students in this shot are actually not in my class. They just came in after school, stayed 5, 6, 7 o'clock in the afternoon because they believed in the vision, because they believed in what was created. So here's a couple of designs. We started off with the top left, which was the wooden table, the 24-foot long one. Our principal was inspired by what the students did and actually updated our computer lab, which was 12 years old, by getting us new Macs, and the students said, can we do something else? So I said, let's create something. So they designed it in Tinkercad, and then we built it. It really built the confidence of the students. The first table took us about 3 months to complete. The second one took us about 3 weeks, which is the long 16-foot one. And the third one took about 5 days. So it was pretty inspiring and pretty awesome. We also talked about other problems and other issues. And here's a short video of like something we put together. So this first example was building a drone for disaster relief, for like, you know, finding people who are like caught in a fire or like, you know, during emergencies. And that was designed on Tinkercad, the drone, which is pretty true to like what actually the actual drone that we actually built was also connected to. In this shot, you actually see the table like working for, this was as we were actually still building it. And here's some housing. So we live in Boston, and there's been a lot of issues in terms of housing and affordable housing. So here's some solutions to how students kind of envisioned affordable housing, from anywhere from container building to apartment buildings. And a lot of thought went into this in terms of the cost, the location, and everything else that kind of comes along with it. So here's a couple of different designs. Our first circuit project was actually by accident. So about 1.5 years ago or so, we came together as a 9th grade team and wanted to do a project about the meaning of resistance in the different classes. So what does resistance mean in English? What does it mean in history? What does it mean in physical education? What does it mean in computer science? And I really love that we would come all together, because I've always tried to like push for that interdisciplinary thing and projects. But at the same time, it was a little bit challenging to kind of think of how to do this. But yet again, Tinkercad came to the rescue when they had the circuit example. So we started off by looking at different circuits, and I tried to tie it in with the with the components of the computer. So we looked at different motherboards, we looked at different video cards, and any other computer component, including the heating unit and the thermostat from like my house, which was kind of the only example that actually could see the resistors. So first, the students just like looked at the examples, and once they looked at it in terms of what they observed, then we started to think about, let's come up with a classroom definition of what a resistor is based on what we're thinking and what we're seeing over here. And then the second day, or on the same day, we started thinking about designing it on Tinkercad. And we started with something very simple. We didn't go into like anything crazy. I just wanted to get them to kind of get to know like what Tinkercad is. And within 1 day, they were able to create some really basic designs that they could actually recreate into their posters for their resistance project, which was really cool for a 2-day project. With that being said, I just want to give you a very quick overview about how, if you haven't used Tinkercad before, about how to create a very simple circuit and some of the other information that is there. Word of caution, this is really awesome, and there's some really, really cool stuff, and it was really difficult to choose and pick what to show. There is a lot of information. Keep on trying. There's nothing that you can't go wrong.
Okay, so let's go through the steps of creating a very simple project using circuits on Tinkercad. So the first thing I'll do is go to tinkercad.com, and once I'm there, I always want to sign in. Once I'm there, students will have their own classroom link. For example, you can join in with creating your account or signing in with Google. This is a very simple and easy process. Just clicking on Google allows you to get there. Once you log in, you see your 3D designs, you see circuits and code blocks. Today we're going to focus mostly on circuits, so we're just going to click on that. I'm going to create a new circuit, and the project that we created was basically needed a LED light, so I'm just going to drag one of those. And I also need a source of energy, so like I'm going to take a coin cell 3D battery. Once I have this, I'm going to need to create some wires between the battery and the light. So very simple to do that. I'm going to click on this side and then on the other side to create the positive side with the anode. And then on the other side, I'm going to click on the cathode. And if I click, I love this feature. If you click on the wire, you can actually bend it so you can really keep your wires nice and straight. Another really, really cool feature about this is that you can actually change the color of the wire. Since this is the negative side, I am going to turn this into black color, and since this is the positive, I'm going to change this into a red color. So I have a very basic loop. It creates a circuit, and if I click the simulation, it will work, but it will have like a little bit of an error. So once I click on the simulation, the light will turn on, but it will say that, hey, listen, there is a lot of current going through this. The current is 61 milliamps, but it's recommended that the maximum is about 20 milliamps. So I'm going to stop the simulation. If I don't do that, I cannot make any changes. And what I need to add is a resistor. So I'm going to move this down a little bit, and the same thing with the wires. And another really cool feature is that it really allows you to move the wires in any direction that you want. So I'm going to cut this, and I do that by clicking backspace. So I selected the wire, click backspace, and it allows me to delete that particular wire. And what I'm going to do is just add a resistor over here. So anode to the terminal. Again, feel free to change the color from green to red, and then the same thing over here, from green to red. And now that I do that, if I click on the resistor, I actually can change the resistance. So I can say, you know what, I can change this to 1 ohm. Right, so let's see what that does. And it's going to work again, and the resistance is now lower, but it's definitely not within the recommendations. So we need to get to the 20 milliamp. To do that, I'm going to click on stop, and I'm going to change resistance to kilo ohm. Once I do that, now I get my light turning on and working with no problem. Let's try something else. At this point you can say, well, there are different types of battery sources. So what I can do is remove everything that we've done so far, and I can take in a different battery. So I'm going to take the 9-volt battery, drag it over here. And then another really cool feature is that you can actually rotate items in the circuit. So I'm going to do the same thing. I'm going to take my positive, go and put it onto the anode, and the same thing with the negative to, and again, it's a little funky right now, but it will work just fine. So what do you think is going to happen? And this is a question that I would ask my students. If I press the simulation, this time is not giving me an error. This time is actually breaking the LED. That's because the current is going through is quite large. So I'm going to stop the simulation and go through the process again. And this allows the students to really break stuff without breaking stuff. So here I go. I'm going to take the, and then what I'm going to do is add my resistor. And the resistor is going to create a circuit that allows me to run the current through without breaking the LED light. So if I run it through, it doesn't matter what the voltage is going to be coming up, the resistor is going to help you with that. Now, you might say, good, great, I'm done with the basics, though I want to do something a little bit different. And that's perfectly fine. You can actually do a lot of cool stuff, because what you can do is actually go to the components and say, let's try some of the starter basic kits. And if I click on it, you can see that there is some stuff that's already pre-built for you. So I can just drag and drop this in here, and you can see the circuit is pre-built with the resistor in place. If I press the simulator, it will start, it will work, and everything is connected and does well. So I would definitely recommend that you play around and check these different things. So here is another one with a potentiometer, and again, it allows you to really turn on the light depending on how much current you're going through. So you can see that the light is turning on and off gradually as the meter is going up and down, as the voltage is going up and down. So there are a lot of really cool examples available here, including other stuff that allows you to really use push buttons and have 3 different types of the LED that has an RGB, for example, right? I can change the color to blue, to green, depending on however I want to do it. And again, reverse engineering, looking at these examples is definitely a really cool thing to do. Another thing that I would like to show, so basically here, if you go to the drop-down menu, you have the basic components. which allows you to really, even like Arduinos and microbits, which is really, really cool. And you can have DC motors and vibration motors and servos and diodes and different types of sensors like distance sensors. So there are a lot of cool features that are available just on the basic components. But if you want, you can also see all components, and this will allow you to do capacitors and diodes and a lot more options for example, neopixels and strips and so on and so forth. We mentioned that there are starters both in basic and in the Arduino. So like here's some other sets in terms of like being able to be created for you, so you can just get started. So don't get scared. Another really cool thing that I like is, just like in the regular Tinkercad design, if you go to the main page and if you go to circuits, or rather if you go to the gallery and you go to circuits, there are examples that are already done. So for example, when we were thinking about the table design and when you need to program the lights, we could use something like this and basically copy and tinker and see how that works. And again, feel free to just look at the code, see how it looks. So basically, if I click on Start Simulation, I will see that the LED strip is going to turn on to different colors. And the way that this is done, if I press on Stop Simulation, is done under this part, which is the code. And this is where it was programmed. And basically, you have like this piece of code that is creating part of the loop and part of the setup for the program. And you can take this, code and actually upload it to an Arduino. And it's really cool because students can just take this exact setup, build it in their classroom or in their home, and then take the code that's been created here and has been tested, and then just upload it and have a fully functional program that does exactly what it does on Tinkercad. So I hope you enjoy. Don't feel afraid or scared or worried about trying different things. You're not going to break it. And it's a lot better to break it here than to break it in real life.
So thank you, Panion, and your I wish your encouraging narration was just kind of a voice in my life to help me through trouble. So thank you so much, and thank you for also helping troubleshoot with the audio and the video. So thank you so much, Panion, and please stick around. So we just have a couple more announcements and a few questions before we get into the question and answer. So Panion will be around later to answer questions that you have as well about his awesome circuits demonstration. But if you've ever used the circuits editor before, please let us know in the chat. So describe a project that you or your students created. And alternatively, if you've never used the circuits editor before, maybe you've never even thought about teaching electronics before, what are some ideas that have been sparked for you in terms of thinking about how you might be able to bring circuits into your teaching, even particularly now just digitally, as Panion so expertly demonstrated for us. So we'll let that keep coming in the chat. Please, share your ideas with other teachers. And before we move on to the question and answer, I just wanted to share some more resources for you in thinking about if you want to get started with your students with circuits. So on the circuits page, so on the Learn page, there's a drop down for circuits with these starters, kind of similar to if you've done with the 3D editor before, the different starters. We also have those for circuits and also code blocks as well. So this is on the Tinkercad page, and there's actually going to be links in the presentation that we'll email you as well. And then also on Instructables, there are also a lot of really awesome projects that you can do with students using circuits. And finally, before we get into the question and answer and a few more announcements, I just wanted to talk about our most trusted news source, which is the Tinkercad blog, and some really cool updates that have been happening lately. So one of them, and I think is super cool, that I started to play around with a little bit, is Annotate within Tinkercad, so you can add notes to your designs within Tinkercad. This is actually a cool example from a student who wrote an Instructable showing how he would design his dream makerspace, and he kind of uses the notes to take you on a tour through the space where he labels things and says where he would put the different equipment. So we thought this was a super cool Instructable. And then another example is even within circuits itself, you can also add notes. And this shows you how with the notes, it's super easy. You can move them around, and you can also drag and drop them onto your different components or assemblies. And similarly within Tinkercad, you do it the same way. I think Notes is on the right-hand side, though, kind of right near Workplane. If you've used Workplanes before, it's kind of similar process as well. So Notes is really fun. Another exciting news is in our first episode, we talked about Tinkercad classrooms, and we did have an update in December, right before the holidays, about how you can now graduate students from classrooms so they don't get stuck in your classroom forever. You can matriculate them onto their next teachers as well. So graduating students from classrooms, more important news from the Tinkercad blog. Thank you, Donald, for that. And last but not least, if you love webinars and your students love webinars, next week we're going to be doing another Make It Big webinar. So I failed to mention that Panion was actually the winner of the first, or one of the grand prize winners of the first Make It Real contest back, I think it was 4 years ago. So this year we have a new Make It Big program that's part of Make It Real, where we have webinar series, different webinars with James Devlin, who's the former fullback from the New England Patriots. And he is engaging students to come up with big ideas for design in the built environment. So the next one is on Thursday. You and your students will be able to meet an architect, or actually a panel of architects, and also hear some cool stories from college students who are using design in order to make their community a better place. So that's next week. There's a little mini link to register, but this should probably be easy to find on the Tinkercad blog as well. And then just last but not least, please stay connected with us. You can do so by using the hashtags TinkerTogether and Make Anything. There's all types of different ways to connect with us through the blog we've talked about, but also Instagram, Facebook, Twitter, Pinterest. So all types of ways to continue to connect with us, and then to connect with us personally, particularly maybe if you have like a lesson plan idea that you want to let us know about. There's an email address, tinkercadlearning@autodesk.com. If you want to share this recording with your friends, or if you want to go back and see earlier episodes, you can do so on YouTube. So Tinkercad has a YouTube channel, and there's a playlist for the Tinkercad Teachers webinar. Last but not least, we think you deserve the world, but right now all we can give you is a certificate, and also lots of free resources and tools and software, and hopefully inspiration. But so when you get your email from us thanking you for joining the webinar live today, you should also in that email have a PDF that you can, that's linked to in a folder, and it will be a certificate that you can use. So if you're doing this webinar series as part of your professional development formally, this could be an artifact of your learning. So before we move into the question and answer, please let us know in the future. So we hope to do another webinar, at least. What topics would you like for us to cover in an upcoming webinar? So we did get a lot of ideas from you in the last one that we tried to translate into this webinar. So do please let us know about that. But at this point, we're going to shift to the question and answer. So we're going to go Brady Bunch style right now. And I'm going to stop sharing my screen. All right, so we're here. Jenny, any questions for the Tinkercad team or for the wonderful teachers that helped us today?
Yeah, well, first of all, we've done a great job here answering questions as they've come in. We've got about 43 questions asked and answered already. Would someone like to comment on libraries for Arduino and what's included in that and how to find out? That's one question that hasn't been answered yet.
I don't know that we have someone to speak to that specifically today.
This is kind of like Tinkercad.
The one thing I'll say about libraries that's important to know is it's pretty difficult for us to make all libraries available, but you can paste them in the top of your Arduino script. So if you get the library from somewhere else, you can just put it into the script. So it doesn't need to be located in our selection, of libraries. So that's sort of a hack that you can use almost anything.
If you have a Arduino in your circuit design, and you select the Arduino, when you get into the code panel, you can there is a little button that looks like a little file cabinet that you can see some of the ones we provide. There's EEPROM, IR Remote, Liquid Crystal, just to name a few. Looks like there's about 10 to 12 of them there that you can include in your code. But yeah, otherwise you'd have to do what Wayne was suggesting.
We had a request to do a microbit webinar in the future.
We gotta get Becky on that. She's back.
Any new questions? Feel free to ask. This is the time to get the experts to answer.
One question I've seen asked a couple of times is on the topic of if teachers can invite co-teachers to work on their classes or not. So I thought that would be a good thing to maybe discuss.
I'll take that one. We're working on that. That's probably the most requested feature since we've launched classrooms 2 years, I guess it's about a year ago. We just had an update this past school year. We are working on what we're calling co-teachers, and that'll allow any teacher who has a classroom in Tinkercad to add another teacher or adult that's helping out the classroom to get access to the students' designs. So the teacher would still do all the creative stuff, but they could have somebody helping with somebody who needs to 3D print or grade or edit, that kind of thing. So that's coming. I can't give you a specific date because I don't think Autodesk does that, but we're working hard on it right now, and it's a high priority of ours.
We have a couple new questions coming in. Here's one. Can you actually program an Arduino and upload?
You cannot upload directly to Arduino right now. We're working on ways of allowing that for both microbit and Arduino. It's possible that we'll get there first, actually, for microbit. It's a little bit easier, but currently right now you download the code and then use Arduino software to upload it into the board.
Mm-hmm. We have a question. Do you think you'll ever add a tool to create custom vectors more precise than the scribble?
Yes. The funny thing is that Scribble was created to give you some capabilities that you never had before. So we really defaulted towards it being a freehand tool. Mm-hmm. We didn't want it necessarily to be a drafting tool. We definitely have some people who are requesting that. I wouldn't say that it's in the near future, but we also want to give some controls like brush size and things that might help with this. So not likely this year, but we will come back to it to add more features.
In the meantime, you can also upload, so you could hand draw things too, or draw them in upload SVGs into Tinkercad, which I know that some of the earrings that I wear are drawn by someone who hand draws them, and then she uploads them into Tinkercad. Yeah.
Yeah, that's a workaround to get a little more precise, is to build it.
Designed in Scribble.
So. You build it in something like Illustrator or Inkscape is free, and then you can. The trick is if you add a bunch of control points in that program, then upload it, then you'll get a closer approximation to what you're intending to design, your design intent, I should say.
We have another question. Is it possible to get Arduino shields in the future? We often use a motor shield and have also used an MP3 shield.
Again.
Sorry, I was answering it. That one's a little over our head. They can share it. If they share it, we can try to get back to them.
Okay, great.
The one thing I will say is generally what we're doing right now with circuits is actually trying to make it so that we can push the age down to younger users. So if you're wanting to teach university level, electronic engineering or that's not really where we're putting a lot of emphasis right now. So just know that we're making improvements, but it may not always be in the areas that you wish. It is very difficult to offer every every component that everybody wants.
I would also say for Shields with Arduino, they are vast and they come out in all shapes and sizes. So it's hard to pick and choose, but also pick one that we think will last long enough to be useful, kind of, because we don't want to make one and then just have it not be useful either.
Yeah, I think, I mean, on that front, I mean, I think I also added a comment on that, is adding a lot of components. So we want to keep the component list sort of small, so that those who are, entry level and coming into it aren't inundated with, way too much stuff to try and just learn some of the basics. That said, if there's some key workflows, let us know. You can let us know at tinkercad-support@autodesk.com, or reach out and open a ticket through the links in the website. But in general, we want to make sure we keep Tinkercad learnable, for everybody.
Okay, I have one other question. I'm very new and love the Learn tutorials. I'm just wondering, how can I find out why certain things are needed? For example, in some of the tutorials, it tells you to add a work plane, but I want to know why we need to do this.
Wow, the whys are a little tough. The best way to learn some of these things, to do them and when you need them, is really through videos. It's not really obvious when students start doing these things for them to know that they need it. We don't really have documentation internally for pointing out, the different tools, and I think that's someplace that we need to get better. A lot of this is just through conversation and people passing on tips and tricks. So I think that we need to figure out ways of helping to facilitate that a little bit more and make it easier for people to ratchet up their skills this way.
We have another question. Are there new features coming to the teacher tools? It would be great to be able to make assignments so students can submit finished files.
Yeah. We have plans. Right now, I mentioned the co-teachers that we're working on, so that's going to allow a teacher to get some help with, wrangling all their students and their designs and things like that. Further on down the road, we have some ideas for better integrations, deeper integrations with Google Classroom, as far as potentially rostering, and we're looking for ideas for that. So if anybody has some strong opinions on that, and we have our opinions, but you guys are teaching, so if you have strong opinions, let us know, because you know better on what you need. The other thing is, somebody just asked this a question about giving assignments to students, and we are looking at ways to do something like this. We don't want to replicate, say, an LMS or a Google Classroom, for example, but we do want to make a way for teachers to be able to do this. So this could probably come a little bit later after we finish some of these other projects. Something like a class project where a teacher can put a design and have the students all work on their own version of that.
There was a question that came up in the chat that I got wrong, actually, and Matt saved me on, that I wanted to bring up again, which was collaborating in the circuits editor, for students to collaborate in the circuits editor. It works a little differently than it does in the 3D editor. I thought it was worth pointing out that you can get students to collaborate on circuits designs by using the share button and being able to use the share link that can be generated there. So it is possible, even though teachers can't quite collaborate with students, you can get students to collaborate on circuits designs together using that feature.
Yeah, and you all have added so many great comments and ideas to the chat, and we just want you to know that we're listening to them, and we do look at these comments to get ideas for improving things here at Tinkercad. So thank you for that. I'm looking to see if there's any other questions we haven't answered.
Are there any questions for our lovely teacher guests that came through the chat at all?
I don't see anything that's come through lately that hasn't been answered.
They're so thorough in their presentation.
Yeah. Oh, those are great. Let's see if there's I'm looking at the Q&A and the chat. So do you think there could be a site to join us teachers to share ideas and experiences on teaching with Tinkercad and look for collaborative projects?
I know for a fact that there's a few Facebook groups out there, and I think there's one even called Teaching with Tinkercad, or Teachers. Actually, I don't know the name of it, but there's a Teaching Tinkercad teacher group on Facebook that's available. But I think there's some other groups out there too that might be useful.
Yeah.
I think there's a Tinkercad for Education one on Facebook. I think that's the one that a lot of people are on.
Mm-hmm. And like with every webinar, we have multiple requests for the Tinkercad t-shirts.
We do too. They're in a box. We can't access.
The office. In the office, unfortunately.
You can't get a vintage one like Wayne is wearing though. That's
oh yeah, so is that one. There you go.
Well, I think that if that's it, I know that our teacher friends have school tomorrow morning on the East Coast. It's late right now.
Thank you for the time.
Any last questions, Jenny, you think, before we sign off?
Well, I'm not sure how simple this one is, but how can we control students in projects designs?
How can we
control? I'm not sure. I might need a little bit more information about that. How can we control students in projects designs?
I think that would actually be to go back to episode 1 from the webinar series. We did talk a lot more about kind of like teacher features and ways to manage your classroom. So that could be actually answered in episode 1 if that teacher didn't check that one out.
Yeah, episode 1 probably in Tinkercad classrooms will allow you to be a moderator of your student, and you can access all of your students' designs and help them if you need to jump into any of their designs, or download it, for example, for 3D printing, or give them any assistance. You can do that as a teacher who has a classroom with them as a student in your classroom.
Mm-hmm. Thank you, Christian. I see a lot of people are signing off. So just before everyone goes, I just want to say thank you to everyone who's joining us, who's joined us for the first time today, or who continues to join us. I see a lot of engagement in the chat when I'm able to look at it, in which even teachers are answering each other's questions, which is really speaks so much to the Tinkercad community. So we're so thankful to you, and particularly so thank you to Mika and Panion in Boston. We are not renowned for pronouncing words, so I'm trying my best. Everyone calls Panion in Boston, so because we're the worst, but he's the best. So thank you for joining us. Thank you so much to the teachers that helped us out today for keeping it real, and thanks also to our wonderful Tinkercad, Autodesk, Education, Instructables team for being here. And we will, I would say, check out the most trusted news source, which is the Tinkercad blog, to find out when the next webinar will be, because I saw that question as well. But for now, thank you. We're going to sign off. Take care. Have a good night. Keep tinkering.